Somewhere out there, right now, there's a planet that swallows light, a star that could erase your body without ever touching you, a cold patch in the sky that might be a scar from another universe, and a line in space you can cross, but never uncross. This isn't science fiction. This is just an ordinary day somewhere in the cosmos. Most of the universe is silent, predictable even, but scattered through that silence are places where the rules seem to bend, where our best equations start giving strange answers, or no answers at all. And here's the thing about this list. The most terrifying place isn't necessarily the one that kills you fastest. Some of these are frightening because of what they do to matter itself. Others are frightening because we still don't fully understand what we're looking at. And one of them is going to force us to ask a much bigger question before we're done. What happens when physics itself runs out of answers? Let's start with a dead star, possibly the most violent magnetic object in the known universe. When a massive star reaches the end of its life, its core collapses under its own gravity. The outer layers blast outward into space, while what's left behind gets crushed into something almost impossibly dense. A neutron star, city-sized, holding more mass than our entire sun. A single teaspoon of that material would outweigh a mountain here on Earth. Now take that already extreme object and push it one step further. Give it a magnetic field beyond anything else we've ever measured. That's a magnetar. Earth's own magnetic field is so weak you never notice it in daily life. A magnetar's field can be roughly 100 billion times stronger. At that scale, the numbers stop meaning much. So let's talk about what actually happens. Get within a few 100,000 kilometers, and the radiation alone, the X-rays and gamma rays pouring off its surface, ends things for any living organism in under a second. No shielding we currently have would make a difference. Get closer still, and the magnetic field takes over completely. It wouldn't burn you. It would simply pull the electrons directly out of every atom in your body, not gradually, instantly. What was once a person becomes a stream of loose particles drawn into the star's field. But here's the part that makes magnetars genuinely unpredictable. Their crust can crack, scientists call it a starquake. And when it happens, the star can release more energy in a fraction of a second than our sun produces in 250,000 years. In December 2004, astronomers detected exactly this kind of burst from a magnetar tens of thousands of light years away on the far side of our galaxy. Tens of thousands of light years is an enormous distance, and yet that burst still reached Earth strongly enough to measurably disturb our upper atmosphere. Now imagine that same event, just a few thousand light years closer. So magnetars aren't dangerous because they're coming for us. They're dangerous because they're so extreme that something happening on the other side of the galaxy can still leave a mark here. But here's the problem. Magnetars aren't even the strangest thing we've found, because sometimes the universe doesn't hand us a violent object. Sometimes it hands us something we simply can't explain. Let's zoom out, past our galaxy, past every galaxy we can see, all the way back to the beginning of everything. The cosmic microwave background is the oldest light in the universe. The afterglow of the Big Bang still visible across the entire sky in every direction right now. For the most part, it's remarkably uniform, but there's one region that refuses to fit the pattern. Astronomers call it the cold spot. It sits in the direction of the constellation Eridanus, and it's measurably, significantly colder than the space around it. At the scale of the early universe, a deviation like that shouldn't really happen by chance. By some calculations, the odds of it occurring naturally are somewhere around 1 to 2%, which raises an obvious question. What's causing it? One explanation is a supervoid, an almost completely empty region of space, far larger than anything we'd normally expect. Light traveling through a void like that loses a small amount of energy along the way, arriving slightly colder than it should. And in that exact direction, there really is a massive void, roughly 1.8 billion light years across. Case closed, mystery solved, except it isn't. Even a void that size only accounts for a fraction of the effect. Some of the most careful studies suggest it explains perhaps 10 to 30% of the anomaly. The rest is still, to this day, unaccounted for. Which brings us to the explanation that gets the most attention and also the most caution from scientists. It comes from a family of theories grouped loosely under one word: multiverse. The idea that other universes might exist alongside our own, each contained in its own expanding bubble. If two of those bubbles brushed against each other very early on, it could, in theory, leave a faint imprint, a scar frozen into the oldest light we're able to see. Under this idea, the cold spot wouldn't be random. It would be a mark left by something outside our own universe entirely. We can't prove this. We can't rule it out either. It remains one of the genuinely open questions in modern cosmology. And if that sounds unsettling, wait until you realize we're already moving through something we can't see. Right now, without you feeling a thing, our entire galaxy is moving, hundreds of kilometers every single second, toward one specific point in space. We call it the Great Attractor. And here's what makes it strange. We can't actually see it directly. It sits behind the crowded, dust-choked center of our own galaxy, an area so dense with gas and stars that ordinary telescopes simply can't look through it. Astronomers even gave this blind spot a name, the zone of avoidance, because for most of the history of astronomy, that's exactly what it was. Using infrared and X-ray telescopes, which can partially cut through the dust, astronomers slowly pieced together what's hiding back there. An enormous concentration of galaxies, part of a much larger structure called Laniakea, our home supercluster. Our own Milky Way is just one small part of it, which means we're not observing this pull from a safe distance. We are inside the structure, being shaped by it, carried along with it, right now, without feeling a thing. But here's the problem. Even Laniakea may not fully account for the strength of the pull we observe. Some calculations suggest there's more mass out there, hidden deeper behind the dust, mass we haven't detected yet. The Great Attractor isn't a black hole. It isn't a single object with a name and a location we can point to. It's a region, heavy, invisible, and for now still not fully explained, from something we can't see to something almost too dark to imagine. TRES-2b is a gas giant, roughly the size of Jupiter, orbiting so close to its star that a full year there lasts under 2 Earth days. That alone would be unusual enough. But here's the truly strange part. TRES-2b reflects less than 1% of the light that hits it. The moon reflects about 12% of the sunlight that reaches it. Ordinary black paint reflects around 5 to 6%. TRES-2b reflects less than 1%. As far as we currently know, it's the darkest planet ever discovered. Its atmosphere does contain light-absorbing compounds, vaporized sodium, potassium, possibly titanium oxide. But even accounting for all of that, the scientists who discovered it admit the numbers don't fully add up. Something about this planet is absorbing more light than the known chemistry alone can explain. And here's where it gets stranger still. You'd expect a planet this dark to be cold. It isn't. Baked by its star to well over 1,000 degrees, TRES-2b actually glows faintly in the red part of the spectrum, like a piece of metal heated until it starts to glow on its own. A planet that swallows nearly every bit of light that touches it and gives back almost nothing except a whisper of heat. The universe doesn't need to break its own laws to break your expectations. Sometimes it just behaves in ways nobody predicted. And now, the final destination. Unlike everywhere else on this list, this is the one place where the meaning of coming back disappears completely. A black hole doesn't have a surface. You can't land on it. You can't crash into a wall. There's simply a region of space-time where gravity becomes so extreme that escape becomes mathematically impossible. That boundary is called the event horizon, and once you cross it, there is no route back out. But here's the part almost everyone gets wrong. The event horizon isn't a physical wall. If you fell toward a large enough black hole, you might cross it without feeling anything unusual in that exact moment. No explosion, no barrier, no alarm. You'd simply cross a mathematical line and keep falling. From your own point of view, nothing dramatic happens at all. But from far away, someone watching you would see something very different. Your signals arrive later and later. Your light stretches and dims. You appear to slow down, fade, and eventually vanish. Not because you stopped existing, but because the information reaching that distant observer becomes harder and harder to receive. Two people, the same event, two completely different stories. That's where black holes stop being simple. As you fall deeper, gravity pulls harder on the part of you closer to the center than on the part farther away. That difference is called tidal force. And if it gets extreme enough, it stretches you lengthwise while compressing you from the sides. Physicists have an almost casual name for the result, spaghettification, but even that isn't the deepest problem here, because eventually we reach a point where our current understanding simply stops. General relativity predicts a singularity at the center, a point of infinite density where the equations we rely on stop producing meaningful answers. Most physicists don't believe that's necessarily the final truth, because at that scale, quantum mechanics becomes impossible to ignore, and our two greatest theories of nature still don't fit together into one complete description of gravity. So the deepest mystery of a black hole was never really what happens to you. It's what happens to the laws of physics themselves. Maybe the singularity is real, maybe it isn't. Maybe our equations are simply incomplete, breaking down at the exact place we'd most need them to hold. Black holes aren't just cosmic monsters, they're laboratories. Nature has built an environment so extreme that the universe itself is forcing us to confront the edges of what we know. 5 places, a star that kills without ever touching you, a cold spot that might be a scar from another universe, a force pulling our entire galaxy towards something we can't directly see, a planet dark enough to disappear while quietly glowing, and a line in space you can cross but never uncross. 5 completely different kinds of cosmic terror. But underneath all of them, there's a single pattern. The universe doesn't need monsters. It doesn't need some hidden force out to get us. It's terrifying simply because it's indifferent. The laws of physics don't care whether something is beautiful or dangerous or inhabited. A star can explode, a neutron star can crack, a galaxy can drift through gravity it can't even see. A planet can disappear into its own darkness, and a black hole can bend space-time until our best theories begin to fail. All of it happens, whether we're watching or not. And maybe that's the most unsettling part of all. We've explored only a fraction of what's out there, and every time our instruments get more powerful, we don't just find answers, we find new mysteries. So maybe the scariest place in the universe isn't a black hole or a magnetar or some hidden region behind our own galaxy. Maybe it's the part we haven't found yet. Because somewhere out there, something may exist that's stranger and more extreme than anything on this list. And right now, we don't even know its name. If you had to send a probe to just one of these 5 places, knowing it would never come back, which one would you choose? Let me know in the comments. I read everyone. See you in the next one.